Assalamu alaikum wa rahmatullah. Today, inshallah, we're going to solve Cambridge exam May-June 2021, paper 41. Let's start it. Question 1. Give the name of the process that is used to produce ammonia from nitrogen. It's a Haber process where nitrogen reacts with hydrogen to form ammonia. B. To separate nitrogen from liquid air, fractional distillation according to difference in boiling points. C. To produce bromine from molten lead bromide. Molten ionic compounds can be produced by electrolysis. To separate undissolved solid from an aqueous solution, of course this is filtration. To produce amino acids from proteins, amino acids can be obtained from proteins by hydrolysis. To separate a mixture of amino acid, here separation need chromatography. Question 2. Complete the table to deduce the number of protons, electrons, neutrons in magnesium atom and copper ion. Identify the atoms or ion represented in the final row. He mentioned here that magnesium is an atom, so number of protons equal to number of electrons. 12 proton, there will be 12 electron as well. A number of neutron can be obtained by subtracting the nucleon number minus the proton number. 25 minus 12 is 13. Copper ion, this is a +2 ion, so it loses 2 electron. Number of electron is less than the proton by 2, so number of proton is 29 and number of electron is 27. And again, to obtain the neutron number, we have to subtract 65 minus 29. The final row here, it's an ion because number of electron is higher than number of proton by 1, so it is a negative charge ion, and number of protons is 17. This is for chlorine, so this is a chloride ion, and to obtain the nucleon number we have to add number of neutron to number of proton. This will be 37. Question 3. Potassium reacts with chlorine to form potassium chloride. Write the chemical equation for this reaction. This is the chemical equation as shown here. Remember to balance the equation because this will be for 1 mark. Potassium chloride is an ionic compound. Complete the diagram to show the electronic arrangement in the outer shell of the ions present in potassium chloride. The first one here on the left is the ion of potassium. Potassium atom has 19 electrons. The electronic distribution for the electron in potassium atom is 2, 8, 8, 1. So potassium is in group 1. It has 1 electron in its outer shell. It will lose this electron to form positive charge ion. So the outer shell electron will be 8 electron and the electronic distribution will be 2, 8, 8. And you have to draw here the 8 electron in the outer shell and the positive charge on the potassium ion. Chlorine atom has electronic distribution of 2, 8, 7. When it accepting 1 electron from potassium, it will be 2, 8, 8. Here again, we will draw the electronic distribution of the outer shell in case of chlorine. Remember to add 1 electron with symbol X as it comes from potassium ion and the negative charge for chlorine ion, of course. C. Molten potassium chloride undergoes electrolysis. State what is meant by the term electrolysis. Electrolysis is the breakdown of ionic compound, molten or in aqueous solution using electricity. Name the products formed at the positive electrode and the negative electrode when molten potassium chloride undergoes electrolysis. Molten potassium chloride means the only ions present here is the potassium ion and the chloride ion. So chlorine gas will be discharged at the anode and potassium metal will be discharged at the cathode. Concentrated aqueous potassium chloride undergoes electrolysis. Write ionic half equation for the reaction at the negative electrode. At the negative electrode, we have protons that will be discharged as hydrogen gas, H2 protons accepting 2 electrons and discharged as hydrogen gas. Name the product formed at the positive electrode, which is the anode. Here we have 2 ions, chloride ions and hydroxyl ions. He mentioned here that concentrated aqueous potassium chloride, so chloride ions present in enough concentration and chlorine gas will be discharged at the anode. Name the potassium compound that remains in the solution after electrolysis. We have 4 ions in the solution. Hydrogen discharged at the cathode and chlorine discharged at the anode. So what is left in the solution? Potassium ion and hydroxide ions. So the potassium compound left in the solution is potassium hydroxide. Complete the dot and cross diagram to show the electronic arrangement in a molecule of chlorine. Show the outer electrons only. Each atom of chlorine has 7 electrons in its outer shell. Remember to use different symbol for each atom, and they are sharing 1 electrons between them, 1 pair of electrons between them. You have to draw in the overlapping part. This will be 1 molecule of chlorine. F. The melting point and the boiling point of chlorine and potassium chloride are shown in this table. Deduce the physical state of chlorine at -75 Celsius. Use the data in the table to explain your answer. Here, it's much easier to draw a number line where -75 can be shown between -35 and -101. Of course, -75 is smaller than -35 and is bigger than 101. So the physical state of chlorine at 75 is a liquid state because -75 Celsius is higher than the melting point, so it's already melted, it's a liquid, and it's lower than the boiling point, so it's still a liquid. So the physical state will be liquid state. Explain in terms of structure and bonding why potassium chloride has much higher boiling point than chlorine. Your answer should refer to particles held together, the forces of attraction, types of the force of attraction, and the relative strengths of these forces. We have to compare between potassium chloride, which is ionic compound, and chlorine, which is covalent compound. Why potassium chloride has high boiling point and melting point than chlorine. Potassium chloride is an ionic compound in which positive and negative ions are held together by strong electrostatic forces of attraction which need high energy to break it. While in case of chlorine, it's a covalent compound and the molecules are held by weak intermolecular forces of attraction. Here, you have to mention the type of force. We mentioned the strong electrostatic forces of attraction, its ionic compound, and for chlorine you have to mention its molecule, covalent, and the forces are weak intermolecular forces of attraction. Here, this will cover 3 points. Nitrogen tetraoxide decomposes into nitrogen dioxide, and this reaction is reversible, as is shown from the equation. A gas syringe containing a mixture of nitrogen tetraoxide and nitrogen dioxide gases was sealed and heated. After reaching equilibrium, the mixture was a pale brown color. State what is meant by term equilibrium. At equilibrium, the rate of forward reaction and the rate of backward reaction are equal, and the concentration of the reactant and product are constant. B. The plunger of the gas syringe is pushed in and the temperature doesn't change. The mixture is initially turned darker brown. After a few seconds, the mixture turns lighter brown because the equilibrium shifted to the left. 1. Explain why the mixture is initially turns darker brown. When you turn the plunger or to push the plunger in, you're increasing the pressure on these gases, so decreasing the volume in which the nitrogen dioxide gas present. Nitrogen dioxide particles comes closer together, so it appears darker in color. B. Explain why the position of equilibrium shifted to left. Increasing the pressure shifts the reaction toward fewer number of molecules or fewer number of moles. So number of molecule in the left side, only one, and in the right side, two. Here the equilibrium shifted to the lower number of molecules. It will be to the left side toward more reactant. C. The forward reaction is endothermic. State what happened to the position of equilibrium when the temperature of the mixture is increased. For endothermic reaction, by increasing the temperature, the equilibrium, of course, shifted toward right. State what happened to the rate of the forward reaction and the rate of backward reaction when the temperature is increased. Increasing the temperature increases both the rate of the forward and the rate of backward reaction. Question 5. This question is about salts. Salts are insoluble in water, are made by precipitation. Lead iodide is insoluble in water. All nitrates are soluble. All sodium salts are soluble in water. Precipitation method is reacting two soluble salts to obtain one insoluble salt. You are provided with solid lead nitrate and solid sodium iodide. Describe how would you make a pure sample of lead iodide by precipitation. Your answer should include practical details and chemical equation for the precipitation reaction. Take care that you are provided with solid lead nitrate and solid sodium iodide. So first, in two different test tubes, add water to both salts, dissolve them to make two solutions, react this solution together by mixing, and filter the yellow precipitated lead iodide that's formed. To obtain a pure sample, you have to wash the residue of the lead iodide with distilled water, then dry it between two filter papers. You have to write the equation for the reaction. Lead nitrate plus sodium iodide, a lead iodide precipitate is formed, and aqueous sodium nitrate in solution. B. Nitrate decomposes when heated. When hydrated zinc nitrate is heated, oxygen gas is given off. Describe a test for oxygen. Test is glowing splint, and the observation, the splint will relight. Complete the equation for the decomposition of hydrated zinc nitrate. Here, to balance this equation, we will take each one separately. First, start with zinc. Here, zinc is multiplied by 2 in the reactant side, so we will add 2 here for zinc in the product side. Then, we will start to balance hydrogen. Hydrogen in the water molecule is 6 multiplied by 2, so it's 12, and it is multiplied by another 2 for the whole molecule, so hydrogen will be 24. 24 means that we have 12 water molecule in the product side. Then for nitrogen, nitrogen here in the nitrate part, it's 2 nitrogen multiplied by 2 from the outside of the whole molecule, so nitrogen will be 4. In the product side, nitrogen dioxide, we will multiply by 4. Finally, to balance oxygen, we have 2 oxygen, one in the nitrate and one in the water molecule. So in the nitrate, we have 3 multiplied by 2. This is 6 multiplied by 2 from outside. This will be 12. And for the oxygen in the water molecule, 6 again multiplied by 2 from the outside of the molecule, it will be 12. So the total oxygen will be 24. To calculate the oxygen in the product side, we have 2 in zinc oxide and 8 in nitrogen dioxide. This will be 10. And 12 in the water molecule. This will be 22. And here 2 in the oxygen, so it will be 24. And here the equation is balanced. Some sulfate are hydrated. When hydrated sodium sulfate crystals are heated, then they give off water. A student carries an experiment to determine value of X in the sodium sulfate hydrate salt. Step 1, hydrated sodium sulfate crystals are weighed. The hydrated sodium sulfate are then heated and the remaining solid is weighed. Describe how the student can check that all the water has been given off. All the water is given off when you heat and weigh, and you find no change in the mass of the salt. So student has to repeat step 2 and 3, continue heating and weighing until obtain a constant mass or fixed mass. When the mass is fixed, means no more water to be lost. In experiment, 1.61 grams of hydrated sodium sulfate is heated until all the water is given off, and the mass of sodium sulfate remaining is 0.71 gram. Determine the value of X by the following steps. Calculate the number of moles of sodium sulfate remaining. Here we have 0.71 gram of sodium sulfate remaining. We will divide it by the molar mass to obtain number of moles. The molar mass of sodium sulfate is 142, so the number of moles will be 0.005. Calculate the mass of water that's given off. Subtracting the final mass from the original mass, we will get the mass of water, which is 0.9. Number of moles of water, the mass of water, which is 0.9, dividing the molar mass, which is 18, we will find the mass of water, which is 0.05. To determine the value of X, number of moles of sodium sulfate hydrate is the same number of moles of sodium sulfate, because we have the ratio is 1:1. So we have equal number of moles here. So number of moles of the hydrated salt is also 0.005. Number of moles equal mass dividing the molar mass, so we can find the molar mass of the sodium sulfate hydrated salt, which is 322. So the mass of water will be 322 minus 142, which is the mass of unhydrated sodium sulfate. Mass of water will be 180. So we have 10 molecule of water. By dividing 180 divide 18, which is the molar mass for water, we have 10 molecules, so the value of X will be 10. Question 6. This question is about iron. Iron is extracted from its main ore in blast furnace. Name the main ore of iron which is used in the blast furnace. The iron ore is hematite. Name the substance that enter the blast furnace in A at A point. Here we are introducing hot air from both sides at A. Name the substance that leaves the blast furnace at B. At B, calcium silicate, which is slag, can be obtained from B. It's in the top of the molten iron because it is less dense. Give 2 reasons for using the coke in the blast furnace. It can act as a fuel or a source of heat when reacting with oxygen, and it acts as reducing agent. B, another iron ore is pyrite, Fe(S)2. Iron pyrite contains the positive ion Fe+2. Deduce the formula of the negative ion in Fe(S)2. Fe(S)2 is a molecule. It has no charge. Total charge is 0. So the S2 should balance or compensate the +2 charge of iron. So the S2 has a charge of -2 to balance the positive charge of iron. So one S ion has a charge of -1. Iron is a transition element. We have this list for the properties of iron. Question 1. Give 2 properties from the list in which iron is different than group 1 element. Iron has a variable oxidation state. We choose from the list. Then, second, act as a catalyst. Give 2 properties from the list in which iron is similar to group 1 element. Iron is a good conductor of electricity and it forms basic oxides. Steel consists mainly of iron. Iron forms rust when it reacts with water and oxygen. Magnesium blocks can be attached to the bottom steel boats, so the magnesium doesn't completely cover the steel, just adding magnesium blocks around the steel core of the ship. Explain how magnesium blocks prevent iron from rusting. magnesium is a highly reactive metal. It is more reactive than iron, so it will be oxidized more easily or oxidized in preference to iron. Loses electron in preference to iron. This will prevent iron from oxidation. 2. Explain why replacing magnesium blocks with copper blocks will not prevent the bottom of the boat from rusting, because copper is less reactive than iron, so iron will be oxidized in this case. Question 7. Many organic compounds contain carbon, hydrogen, and oxygen only. An organic compound V has the following composition by mass, and you have to calculate the empirical formula for this compound. First, we will write each percentage for each element: 48.65 for carbon, 8.11 for hydrogen, and 43.24 for oxygen. Then dividing each one by the molar, for the first one by the molar mass of carbon, and hydrogen divided by 1, oxygen divided by 16, which is the molar mass of 16 of oxygen, 16. To get the number of moles for each element, it will be 4.05 for carbon, 8.11 for hydrogen, and 2.7 for oxygen. When we get this ratio, we will divide the three numbers by the smallest number, which here in this case 2.7. We will obtain the ratio 1.5 to 3 to 1. The ratio should be in a whole number ratio, so we will convert this 1.3 to 3, 1.5 to 3 by multiplying by 2, and we will multiply the total ratio by 2. It will be 3 to 6 to 2. So the empirical formula is C3H6O2. Compound W has empirical formula of CH4O and a relative molecular mass of 32. Calculate the molecular formula of compound W. The molecular formula equal to the empirical formula multiplied by N. So here we will calculate the mass of this empirical formula: CH4O, 12 for oxygen, 12 for carbon, 4 for hydrogen, and 16 for oxygen. This will be 32. So the empirical formula mass is equal to the relative molecular mass. Both are 32, so N is 1, and the molecular formula is the same as the empirical formula. Compound X and Y have the same general formula. They are both carboxylic acids. Deduce the general formula for compound X and Y. The general formula for all carboxylic acid is CN H2N plus 1 plus COH. Draw the structure of compound Y. Show all the atoms and all the bonds and name compound Y. Compound Y, C4H8O2. Here, C4, we will draw 4 carbons and draw the carboxylic group, and then put all the hydrogen connected to the carbon. The name is butanoic acid. Question 3. Give the name used to describe family of similar compounds which have the same general formula and same chemical properties of the same functional group. This is homologous series. D. Propene is unsaturated hydrocarbon. The formula of propene is as shown. State the color change observed when propene is added to aqueous bromine. Aqueous bromine or bromine water is a test used to identify double bonds. So here the color will change from brown to colorless. Propene can be produced by cracking of long chain alkane. Bentadecane, which has 15 carbon, is cracked to produce alkane and propene in a ratio 1 to 2 molar ratio. Here we have to use this ratio to balance the equation. Okay, propene has 3 carbons produced in ratio of 2, So you will add 2 here, and 2 multiplied by 3 is 6. 6 carbons subtracted from 15. So we will have 9 carbon left, and the other product that produced from this cracking, C9H20. Propene can be converted into polypropene. Name the type of polymerization that occur when this propene is converted to polypropene. Addition polymerization. Complete the diagram here to show a section of polypropene. To draw an addition polymer, first you have to remove the double bond, then leave 2 open ends from each side of the right and left carbon. Then repeat the unit to obtain polypropene. Here we come to the end of our exam. Thank you for watching. Wish you all best of luck.